naught, again, starting point, right? So again, this is the starting point, and they represent the initial position at t equals 0, okay? Then we have x is v naught cosine t plus x naught. Okay, now we've introduced this v naught. Ooh, maybe this is why I don't like it. V naught is the initial speed, okay? Then we see y is, holy crap, what's going on, right? Y is -1/2 gt squared. This is accounting for gravity because we are looking at projectile motion. So if you're throwing a ball, you're looking at the path, the curve of a ball as it travels when you're playing catch, whatever. Like this is, there is gravity involved. We can't say, oh, pretend there's no gravity. That would make zero sense, right? Then the ball floats in the air and it just floats up into space, right? So doesn't make sense. So we have to consider that, and it's negative. It's pulling it down, -1/2 gt squared plus v naught sine theta t, right? Again, that's our t part, and then plus y naught. That was from the previous one again, so that's fine. So now we are assuming negligible air resistance. So based on this equation, we are assuming the wind isn't blowing too hard down or left or right or up. And we're just assuming it's a calm, still day. And this is what we find, right? So we can take a look now. And they show you this initial speed. So say the speed, is this, and then, but the motion is this, and the theta is theta is the angle at which the direction of the ball is moving at that moment. So it's related to t as well, because if I look at this point on the curve, right, my theta is different than at the very beginning when I started this up here, right? So my theta is very different there than when, at the end of the throw as the ball is coming down when it's there. So theta is also based on time. All of this is going to be based on the time. And I want to say, so I also on the test, so okay, the reason this shouldn't be so bad is because on the test, you're going to get these equations. So I'll remind you, like in the problem, of these equations, and you just have to know how to apply them, how to use them, right? So okay, this would be way worse if it just is a more of a thinker of a problem because there's words to read, and I'm a math person, and so I like numbers and nothing else, or maybe letters and nothing else, but not actual words, right? So this is why I just don't like. I said I didn't like this problem, but it's not so bad. So looking at the example, problem 6, a ball is thrown from a height of 5 feet at a speed of 80 feet per second and an angle 60 degrees from the horizontal. So this is, again, they're giving us a lot of information here: 5 feet from the ground, 80 feet per second, 60 degrees from the horizontal. Okay. So the information they gave us is 5 feet from the ground. That's our y distance. So that's y naught. So right at the start of the throw, maybe I was leaning back with it and it's 5 feet above the ground. That's y naught. The 80 feet per second, this is v naught. That's our initial speed, right? Yes, of course it slows down because it falls to it. Someone catches it and the speed is 0 at the end, right? And then 60 degrees from the horizontal. So we're just going to say theta is 60 degrees, and we aren't going to worry about what it is at the end or when it's moving. We're just thinking about the very initial beginning and then writing it as a function of time. Okay. So it says write parametric equations to describe the path of the ball as a function of g time. This is where we go back to these equations up here, right? And we say, all right, what do we got here? So I can start off the bat just by writing what I know, and then see if I need to simplify, see if anything changes. So x is v naught cosine t. So it's going to be 80 cosine 60 degrees and then t plus, x naught is 0. So we're assuming like, because the x naught would be the horizontal distance, and we're just going to assume it's the initial is like 0.5, right? And then from there, our x is moving. Yeah, exactly. So we do know we are fancy, right? So we do know that cosine of 60 is 1/2, right? So this, I'll just write 1/2. So it's 40t. And then you don't need to write plus 0 because what is that, but I will make a note that this model starts where the ball is thrown. So x naught equals 0. Like maybe they might say, it starts when the ball was just like a second after it was thrown, and that's where your x naught would be different. But in this case, it's not. And then for y, well, we can't ignore the y. Yeah, I don't know if you're joking. So for the y, it's negative 1/2, right? Then g, now keep in mind, if it's feet, and again, I think on the test, I'll give you whichever you need. If it's feet per second, it's 32. If it's meters per second squared, it's 9.8. So we have 1/2 times 32, that's our g, and then t squared plus v naught, so again, 80 sine of 60 degrees times t, and then plus y naught, which was 5. Okay, so this equation is ugly, but we can just leave it once we simplify. So I know that, this right here can just simplify to be negative 16t squared. Okay, sure. And then sine of 60 is √3/2, right? So I can say y equals, so here's my x, I'll circle that, right? Y equals negative 16t squared plus I have 40√3/2. Not over 2, 80/2 is 40. So 40√3 and then t and then plus 5, right? So this is these are the parametric equations that we found here. So this are the parametric equations, and they describe the path of the ball at time t. So if I wanted to know when does it hit the ground, I could just set these equal to 0 and solve. And you could do the quadratic formula for y, kind of gross, right? Or if I wanted to know when, what are x and y when the time is 10 seconds? Is this still somewhere in the air, or 2 seconds? Is it really, really high, or is it where's the ball at, right? So we could do this. Wait, y is negative 16. It's negative 16t because of this negative in the equation above. So remember this equation up here, y equals, like the equation that we're following, it's negative 1/2 gt squared. Or you could just consider, if it wasn't negative, you would just change these to be negative, like the pull of gravity is negative 32 feet per second squared, or negative 9.8 meters per second squared. But instead we just think of the gravity as positive, and then we throw that negative in front. So the second one is right, not the first one, if that makes sense. Okay, hopefully it does. Okay, so so now from here, they're asking some questions. Okay, good. Okay, I was going to say, I don't know why we didn't do anything else, but, and I can't remember on your test, like this to me is the more fun part. I think getting the equations is kind of crazy. But, so now we can say, when does the ball reach its maximum height, and what is the maximum height? So, the height is the y, right? Because if you think of the x and y coordinate plane, when the ball's being thrown, the height is the y, and the x represents the distance, distance it's going, right? So for part A, we're really just concerned about y, and this, well, we want to know when maximum height. And so this means when is the t, and maximum height is max y, right? And so we want to find the maximum of y of t, that equation that we just, this equation up here that we just found. And the maximum is at the vertex. It's a quadratic, right? You see this squared and the t. So it's a quadratic. So the maximum, it should look, something like, this or whatever. And this will be the max height. Now we don't exactly know, like we have the formula, right? The equation for y, but this is a throwback, and maybe this is also in the review. But the vertex can be calculated by doing negative b over 2a. I don't know if we remember this, right? If you don't, this is how, if you have a quadratic formula and you have like y equals ax, or I'll use t, a t squared plus bt plus c, negative b over 2a is the vertex, right? If it's in this form. And this is the form that, this is exactly the form that this is up above, right? So if I want to find the height, the maximum or the vertex, right? My h, so like this would be like hk or vertex. So if I want to find that, then I'm gonna just use part A. So I'm gonna say negative 40 square root 3, that's the B, over 2 times negative 16, that was the A, right? So then the negatives will cancel each other out, and I get 40 root 3 over 32. Well, I guess, or I could have said 20, 20 root 3 over 16, but we need to get a decimal here because I don't know what that means, right? And this is about 2.2. Now, what does this represent? It actually doesn't represent. So remember, this is y of t. So it's not the actual height. The actual height will have, this is t. We'll have to plug that into the y equation to get our height, if that makes sense. So 2.2, this is 2.2 seconds. So this, because like we just solved for this 2.2. And now we want to know k. Now to get k, this is the actual y value, right? So this would be negative 16 times 2.2 squared plus 40 root 3 times 2.2 plus 5. And again, I would just throw that in a calculator and let's just, it's about 80. I think it's like either 79.99 or 80.0 something. So I'll just say it's 80 and we were in feet. So this ball goes up 80 feet is the max height from the ground. Now this is from the ground, which means it's being thrown 75 feet because it started at 5, right? It was released out of my hand at 5 feet. But okay.
That's true.
Yeah, right. But it is the maximum height above the ground. That's the max height of the ball. So that is perfectly accurate answer. So max height is 80 feet. Oh, it does say round in the nearest 10. So maybe 80.0 I should have said, but oh well. Now part B is asking, use technology to determine when the ball hits the ground. How far is that from where it was thrown? Okay, so again, what are we looking for? When is t, ball hits the ground is y equals 0, and how far is x equals what? So they're asking for a lot, well, sort of a lot here, but the y equals 0, all we have to do, so because if we're assuming, this is where it's a little shady because we're going to assume that, we are going to assume that at the beginning it's at the ground, even though technically it's 5 feet up, because the vertex is going to be halfway, like at the vertex, the ball then starts to fall, and then that's halfway, and halfway, like double that time, it should be on the ground. right? Now granted, yeah, this makes me think this is not right, but let's see, and maybe you'll find other things in your textbook, but it's y
You don't
equals
use the
0.
quadratic.
You can, but but you can also just say, take the previous part, 2.2 seconds that we
Yeah.
found up here, and double it.
Okay.
So that's what I'm going to do. If you did the quadratic formula, I think you get, maybe that's where you get like 4.256, Jakob, maybe. But so I'm just going to say T is 4.4 seconds. And if it was like, how did you get that? Well, I doubled the previous one. Because if that's the vertex, it's around there, right?
Yeah, I use the quadratic formula.
But yeah, so if you use quadratic, it's
But
slightly sooner.
eliminate the
Yeah, but that's okay. But it's 4.3, 4.4. We're close enough, right?
It did say like minimum weight
eliminate
resistance.
the one of them.
Yeah, it's rounding error, right? Yeah, but yeah, it's around there. So either way, you're correct, right? Yeah.
One is
Now-
0.07 and the other is 4.
Yeah. Okay. See, so there you go. Yeah. So either way, you can figure this out. 4.4 or around there is good. Now, to figure out how far from where it was thrown, we want to take our X and we want to say, okay, X is 40T. So if it's about 4.4 seconds, we'd say 40 times 4.4, and that's going to tell us how far the distance X like horizontally, right? So this is about 176 feet. Right? Or at least that's what we're calculating here. And again, if you used 4.25 or whatever, maybe you get slightly different, but around 170 to 180, something like that, right? And then the last part C, is asking eliminate the parameter and write an equation in rectangular coordinates to represent this path. Okay, so to eliminate this parameter, this is algebraic. So we're going to take X equals 40T. It's the simpler equation. And we're going to write it as T equals X over 40. Right? And then we're going to take this and we're going to replace this into the Y equation everywhere that I see T. I'll just rewrite it in terms of X. So I'd say Y equals negative 16 X over 40 squared plus 40 square root of 3 times X over 40 plus 5. And then I can simplify this. So I'll simplify by, negative 16, this is X squared over 1600, right? Because 40 squared. And then these 40s can cancel each other out, right? So I'd get plus square root of 3x plus 5. And then negative 16 over 1600 also simplifies. So I could say Y equals negative 1 over 100 X squared plus square root of 3x, or I guess you could say 0.01, right? And then plus 5. Or you could also just put like this first, you could put X squared, negative X squared over 100. Either way. For some reason, I always write that coefficient and then X squared, but yeah, either way. Excuse me. So this is our equation in terms of X and Y. And if we were to like graph it or see, we'd only be interested in a portion of it where it's being thrown, right? Not the entire, because remember, this is a quadratic and it probably looks something like, like that. But we only want like this piece to the ground, like, and it would be going like that or something like this, right? So that is the essence of parametric equations. Yeah, so Veronica's asking the question on the test, will it have this many parts? I don't remember. I know it has multiple parts, but I don't remember how many. I know it didn't take up a whole page, so I think it only had A and B, if that makes sense. So I think it asked like 2 parts of this 3 parts that we did, if that, okay. And I'll verify that for you guys before the test, because I'll remind you again, in December, like what's on the test, and like we'll do some practice, and I can remind you again, like, hey, we can even refer to our notes and say, oh, I mean, know how to do A, B, and C, but only 2 of these parts will be asked of you, right? So yeah. And actually, there was technically this was A, and then it was B, C, D. So I know for a fact it's not this many parts on the test. I think it's like 2 out of the 4 or something like that. Yeah, it's definitely not as bad. And then this little extra practice, so it's funny because I don't actually know why. I don't know if they wanted, so if you think of, well, X is e to the 2t, but if you think of X as e to the t like squared, and Y is e to the t plus 4, I think in this case, I might reverse this and say y minus 4 equals e to the t. I mean, okay, so there are so many different ways to solve this, and this is extra practice really for you. I wasn't actually planning on doing it either, but I think I'm just going to run through like some thoughts of mine, and you can also try it a different way and see what you get. But I would think, okay, so y minus 4 is this, so then I would get x equals y minus 4 squared, right? And this is basically a parabola. So this, okay, we could also write it out, y squared minus 8y plus 16. But so this is a parabola, but it's sideways, because the x and y are switched. So you could also do square root. Like another way you could do this is you could say, so e to the t is, well, square root of x, but is it plus or minus? You'd have to do a little work there. And then you would say y equals, okay, is it plus or minus, but square root of x plus 4. And this is where, and again, I won't maybe finish this, but the sideways parabola is going to be, something like some type of side. But when you do it this way, you'll learn, oh, is it the positive or is it the negative? So based on t here, it can only be like the upper half maybe, and maybe it's not the lower half, right? Or something like that. And again, I'm not graphing this exactly, but this is also, I don't know if this is like a book problem or homework, but I don't even remember doing this on your test. So I think it's just some extra practice for graphing parametric equations and using exponentials. So I'll kind of stop there and let you, think on that one. But yeah, so, and we're ending on time, which is great. Let me save this before I lose my mind. Okay. So this should be, this was 11.6. I'm pretty sure I made all of the homework problems. I made them, I didn't change the due date, so they're probably due Sunday evening. If people want me to go ahead and make 11.6 and 11.1 due next Tuesday and continue to do that, just shoot me an email or tell me I can do this, but I just haven't. And 11.6 was today, 11.1. So we're going, again, a weird order, but it should be in order on Blackboard as well, where the notes are posted. So 11.1 is going to be this Thursday. And then next Tuesday, it's probably 11.2 or 3, whichever is coming next. So again, if you will be out next Tuesday, this is okay. Just make sure you get the notes online, and I'm hoping I don't fall behind in our schedule. But yeah, so thank you guys. And I guess, I didn't think of a question of the day for today. It was, I mean, if anybody has their own question, I should just start tabling it to you guys. But I've nearly run out of questions. I don't know why.
Something Thanksgiving related? No, I guess it's, so we still have time.
Yeah, or maybe, yeah, and Joseph, no written homework for the rest of the semester. So, yeah, yay. No written homework, no cumulative final. What a good day for you. Yeah. All right, look at this. All right, I'm gonna write all these down because now let's do college major. Oh yeah, well, favorite Thanksgiving stuff. We can do that Thursday and next Tuesday, but today maybe it's only slightly too soon. I mean, not really, but right. So today, okay, I'm loving all of these ideas. Let me type them all out in my notes here. But for today, let's just do your major if you have one, or if you whatever you plan to major in, or maybe if you've majored in something else and you're going back to school to do something else, that's fine. Yeah, and if you don't know, you don't need to know. So that's perfectly okay. My sister changed her major like 6 times, but she also graduated in like 5 or 6 years. So, but hey,
What was her eventual?
her final one ended up being, well, it was so bad. It ended up being like marketing, and she doesn't even